binomial distribution. So let us get to this question first. So we have male and female, and let us say there are 4 candidates. We have candidate A, B, C, and D. And according to the poll, okay, the supporting rate for all these candidates, it is as follows. And so this is the table, okay? From this table we know the probability of a male will support candidate A is 0.2. And the probability that a male will support candidate B, that's also 0.2. And this is for the female. And so let's put down the probability here. It will be 0.35, 0.3, 0.25, 0.1, and 0.57, and 0.43. So the question is, if we get a person, if we choose a person supporting A, what is the probability that this person is a female? So we already choose a person, and we know this person supports A. Okay, this person supports A. What's the probability that this person will be a female? So in this case, we are looking for the probability that he or she supports A, and we would like to know what's the probability that this person is a female. Okay? And so in this case, it's probability of A, okay, and probability of F and A. So probability of A, what is that? What's the probability of A here? 0.35, right? And what's the probability F and A? That's 0.15. Okay? Okay, of course in this case we are able to find the conditional probability and also the marginal probability, okay? It is all here. So we can have all sorts of combinations of questions. And also from this table we can have questions on Bayesian, right? Bayes theorem, okay, Bayes theorem. So just one table we can have a lot of questions. I think that's about it. That's the problems that I have. Any questions? We will get to uniform distribution now, okay? Uniform distribution. So you should, when you get to the practice session, you should ask Mr. Hu to give you some practice problems on covariance and correlation coefficient, okay? So now let's get to discrete uniform distribution. Uniform distribution means that the probability that is going to happen is the same, okay? So let us say we have x is equal to 1, 2, 3, up to n. And of course, this is a uniform distribution, so the probability that each one going to happen is fxi for any I in this, it is equal to 1 over n. So for every distribution, we are interested in the mean and variance. So now let us try to find out the mean in this case and the variance. Okay? So expectation of x, that is the mean, should be equal to summation x times fx, right? And in this case, we have 1, 2, 3 up to n, right? And also we have fxi for any x in this distribution, that is 1 over n. So it will be 1 times 1 over n plus 2 times 1 over n and plus n times 1 over n, right? Any questions here? So basically we have 1 over n, okay? And inside we have 1 plus 2 plus up to n, right? Okay, and how much is this? This is 1 over n, and this is actually n times n plus 1 divided by 2, right? So in this case, the mean is equal to n plus 1 divided by 2, okay? So if we know this distribution, this random variable, is a distribution of uniform distribution, then we know the mean is equal to n plus 1 divided by 2. And now we need to figure out what is the variance. Okay, we need to figure out what's the variance. Okay, let us try. Now we are going to find out variance, okay? And variance will be equal to expectation x squared minus mu x squared. Okay? And so it is equal to 1 squared times 1 over n plus 2 squared times 1 over n plus n squared times 1 over n minus n plus 1 over 2 squared. Okay? So you have 1 over n, and then inside 1 squared plus 2 squared plus up to n squared and minus n plus 1 squared. Okay? Any questions so far? So what is this? This is 1 over n times 6 over, let me see, what's this? Yes, n plus 1 and 2n plus 1 minus, okay? So in this case, you need to know this formula, okay? You need to figure out this formula. You have to try to figure out, okay? And then you have n and n cancel out. So you have n plus 1 times 2n plus 1 divided by 6 minus, okay, because this is n plus 1 over 2 squared, so it is this. And here we can factor this out, okay, because there is a common factor. There's a common factor n plus 1 and n plus 1. So we get n plus 1 out, and inside you have 2n plus 1 minus n plus 1 here, okay? And so n plus 1, okay? You can try, let me see what's going on here. It should be 4, right? It should be 4, okay? It should be 4. And the common factor here will be 12, okay? The least common multiple will be here, okay? Least common multiple. And so you have, this will be 4n plus 2, because this is 12, right? And this is 6, so you have to multiply this by 2. So it's 4n plus 2. And minus here, it has to be multiplied by 3. So 3n minus 3. So what you get? You get 12, and here you have n plus 1. And times 4n minus 3n, you get 1n left. Plus 2 minus 3, you get minus 1. So what you get? N squared minus 1 divided by 12. So if it is a uniform distribution, the mean is n plus 1 over 2. And the variance is n squared minus 1 divided by 12. Okay? So basically, this is the uniform distribution. If it is a uniform distribution, you know the probability is all the same for all the data points there. And the mean will be this, okay? And the variance will be this. Any questions? Now we want to get to binomial distribution. Okay, binomial distribution. Bi, okay, what does bi mean? Bi means 2, okay, bi means 2. So, you know bicycle, right? Bicycle means they have 2 wheels, okay, bicycle means they have 2 wheels. Binomial distribution, basically there are some properties here. This distribution is proposed by this person called Bernoulli. And so we have a Bernoulli trial. Basically, Bernoulli trial, it means that you do an experiment, okay? You do an experiment, and in this experiment, there are 2 kinds of possibility. Oftentimes we say success or failure, okay? In this case, you have two kinds of possibility, success or failure, okay? And in this experiment, the probability of success and the probability of failure will not change, okay? So whenever you try it, the probability of success or the probability of failure is always the same. And also, in each experiment you do, the results are independent of each other. So in this case, there are several things here. First, in this experiment, there are 2 possibilities, success or failure. The second one is, of course, there's a probability of success and a probability of failure. In each experiment, the probability of success will not change, and also the probability of failure will not change. And in each experiment, the result are independent of each other, okay? Oftentimes we say the probability of success is equal to P, and the probability of failure is equal to Q. And because in this case we have only 2 possibilities, right? So what is Q equal to? Q should be equal to 1 minus P, right? Q must be equal to 1 minus P. I think you should concentrate on the class. Okay. So you have all these results, and let us try to find out what is the mean and the variance. Okay, so now let us say this. We cast a coin once. Okay, we cast a coin once, and if it is head, okay, we say X. When it is head, then X is equal to 1. Okay, when it is tail, then X is equal to 0. And in this case, of course, we know if we cast a coin, the probability you get head is P, right? And the probability you get tail, the P will be equal to 0.5. The probability you get head is 0.5. The probability you get tail is also 0.5. But let us say the probability you get H, that's head, is equal to P. And of course, then in this case, we say it is equal to Q, because we assume we don't know whether the coin is a fair one or not. And so when it gets head, we say the probability is P. When it gets tail, then the probability is Q. Of course, because you cast a coin once, the only possibility is head or tail. So these two things add together, P plus Q should be equal to 1. And now let us try to figure out what is the mean and variance in this case. Because we say X has two possibilities, right? It can be 1, it can be 0, right? And Fx, that's the probability. If X is equal to 1, what's the probability? P. X is equal to 0, probability Q. Okay? So in this case, if you are required to calculate the mean, that is expectation of X, what should that be? Expectation of X should be equal to summation X times Fx, right? And so X is equal to 1. What's the probability there? It is equal to P, okay? And the next X is equal to 0 and times Q. So what is the probability? What is the mean there? The mean is equal to P, okay? The same thing, let us try to figure out what is the variance, okay? The variance. Okay, the variance of X, as we say, it should be equal to expectation of X squared minus mu X squared, right? Okay, so this one is summation X squared times Fx minus mu squared, right? Mu is equal to P, so that is P squared. And in this case, it will be 1 times P, right? And plus 0 times Q, because 1 squared is equal to 1, 0 squared is equal to 0, and minus P squared. So it will be equal to P minus P squared, right? And we can factor P out. We get P out, 1 minus P, and because 1 minus P is equal to Q, so that's equal to P and Q. So if we cast a coin once, and the probability that, and we assign If it is head, then x is equal to 1. If it is tail, then x is equal to 0. In this case, okay, in this case, then we can find out that the mean in this case is equal to p, okay? And the variance here is equal to p cubed. So the same thing we can say if we assign, okay, we say there are two cases, right? Success or failure. If it is success, we say x is equal to 1. If it is failure, then we say x is equal to 0. That is exactly the same as what's going on here, okay? It's just that we say catch a coin and it is head, is tail. And it is success, is failure, okay? That's basically the same thing. And we say if it is success, we say x is equal to 1. If it is failure, then x is equal to 0. So in this case, this is a Bernoulli trial. And we find out that if it is Bernoulli trial, okay, and in this case, we know the mean will be p, and the variance will be p times q, okay, p times q. So we talk about Bernoulli trial. Then what about binomial, okay? If we say it is binomial, if we say it's binomial, then we try n times. Maybe we use this n. We try n times, okay? So for Bernoulli, we only try once, okay? For Bernoulli, we only try once. But for binomial, we try n times, right? So in this case, x can be only equal to 1 or 0, right? Because we only try once. So there can only be one failure or one success, okay? But if we try n times, there can be n success or n failures, and n minus 1 success or n minus 1 failure, and up to even, if there are n success, that means there is no failure, right? If there's n success, then there's no failure. If there is 0 success, that means there is n failure, right? So if this is success, then this should be failure, okay? And this 1 time, 2 times, etc., okay? So for once, that's easy. For n times, we have to try to figure out what are the possibilities and probability there. Okay, in this case, we try this first, okay? N success, right? For n success, okay? What does that mean? Because each time, the probability you will get a success is equal to p, right? Each time, okay, we know ps is equal to p, and pf is equal to q, right? So in this case, you try n times, and you get success for n times, right? So what would be the probability? So the probability will be equal to, so in this case, as we know, we assign, say, if it is equal to, if it is success, then we say x is equal to 1, right? If it is failure, say x is equal to 0. And because we try n times, right? We try n times. If every time you get a success and you get n times, so what should that be? X should be equal to n, right? So x will be equal to n, because in this case you get n success, okay? You get n success. For each success you get 1. You get 2 success, then you get 2, right? If you get n success, then x is equal to n, okay? And so in this case, what should that be? Because each time you get a success, the probability is p, right? And how many times you get? You get n times. And we know the experiment is independent of each other, right? So that should be the multiplication rule. So it should be p to nth power, okay? P to nth power. Now, if you have x is equal to n minus 1, what does that mean? That means you get n minus 1 success and 1 failure, right? Okay? So in this case, you get n minus 1 success, okay, and 1 failure, okay? But you have to be very careful, right? Because we have n experiment, okay? We have n experiment. It can be the first one you get failure, or second one you get failure, or the nth one you get failure, right? So in this case, how many possibilities there? There are n possibilities, okay? N possibilities, okay? Because n trial, 1 failure, 1 F, and n minus 1 success, okay? If it is the first one, okay, that you get failure, that's one possibility, right? If it is the second one you get failure, that's another possibility. So how many possibilities you can get? N possibilities, okay? The same thing here. If n is equal to n minus 2, right? What does that mean? You get n minus 2 success and 2 failures, okay? So the same thing here, you have n minus 2 times q squared. But then in this case, you have 2 failure and n minus 2 success. And really in this case, okay, in this case, do you really care which one is failure and which one is success? You don't. You only care about the numbers. So in this case, what is the rule? The rule is what we call combination. So we have permutation and combination. What is combination? And what is permutation? Okay? In this case, the reason we call this combination, we only care about how many different things you have. We don't really care about the order, okay? Whether it's first one, the second one, we don't care. But for permutation, we care about the order, okay? We care about the order. So in this case, what should we get here? We get, there are n trials, okay? There are n trials, and we want to have among these, n minus 2 would be success. And of course, in this case, 2 failure will be there, okay? So this is the combination. So the same thing here, what you get? If x is equal to 0, then you have n trials, you don't get any success, and this is p0 times qn, okay? So basically, this is what we call binomial distribution, okay? The probability distribution function is here. So let us say in this case, we want to know, in this trial, is a Bernoulli trial, we try n times, then we get binomial distribution. And in this case, we are interested in the number of x, okay? If x is equal to, if it is a success, then we get 1. 2 success, we get 2. So x denotes is the number of success, okay? And of course, you can say some other variables, but here we are interested in the number of success. And if we want to know, okay, this is the number of success, then what is the probability? So I use capital letter X to denote the random variable. So this is the random variable. And this is a script x, okay, little x. It is a specific number, okay, it is a specific number. So we want to know how many successes there are, okay. Then in this case, of course we know the total number of trials is n. We have n trials, and this is the number of success you get, right? And the probability is this combination times p to x power and times q to m minus x power. So this is the probability function of a binomial distribution. If it is a binomial distribution and you want to know the number of success, okay, this is the probability function. Any questions so far? And now we want to get to what is the mean and variance of a binomial distribution. Because in a few minutes ago, we just talked about Bernoulli, right? If it is a Bernoulli, okay, we know the mean, okay, if x is a Bernoulli trial, we know the mean is p and the variance is p times q, right? This is the mean, this is the variance. And we say, if it is a Bernoulli trial, how many times do we try? We only try one time, right? We only try one time. But for binomial distribution, how many times do we try? We try n times. We try n times. And remember, we talked about this before. And in a binomial distribution, okay, the trial for each time is independent of each other, right? We say the trial are independent of each other. So what does that mean? We can say the first trial is x1, right? The first trial is x1, so we have x equal to 1 or 0, right? And if it is equal to 1, we say the probability is p. And if it is equal to 0, the probability is q, right? And we have second trial, the same thing. The second trial, you have two possibilities, right? X is equal to 1 or 0, that is p, that is q, right? And up to we have n trial, right? We have n trial. And we have that is equal to x, 1 or 0, p or q. So we have so many trials, n trials, right? For each trial, we have a possibility to get 1 or 0, and the probability is p or q. For the second trial, the same thing. We can get 1 or 0, and that's p or q. We have n trial. If you look at only one trial, that is Bernoulli, okay? If you look at only one, that will be Bernoulli. If you look at the whole thing, 1 to n, what is that? That's binomial. And remember, we talked about this before. If we have expectation x and y, okay? If we have expectation x plus y, what is the expectation there? It will be equal to expectation x plus expectation y, right? Remember this, okay? What about this? What about variance x plus variance y? If we have variance x plus variance y, if you check your note, okay, it will be equal to variance x plus variance y, and what else? And plus 2 covariance x, y, right? And we discussed this before. If x and y are independent of each other, what is this? What should be the value here? If x and y are independent of each other, this one is equal to, this one is equal to 0, right? If they are independent of each other, it is equal to 0. Now we are trying to use the information we have and try to find out the mean and variance of a binomial distribution. And we know In this case, the binomial distribution is we do Bernoulli trial n times, okay? And we know for each trial it is independent of each other. So because of this, okay, because of this, this is what we're trying to figure out, right? And we know for this, actually there are n numbers here, right? So as a matter of fact, x is equal to x1 plus x2 plus up to xn. Because in this case, the first trial may be success or failure, so maybe 1 or 0, right? If there are 5 success, then this will be equal to 5, okay? So basically, the number we are interested in now, this is a binomial distribution, right? This one is for the Bernoulli we try n times, okay? So then what is expectation of x? Expectation of x is equal to expectation of x1 plus x2 plus xn, right? Okay, so what is that? Expectation of x1 plus expectation of x2 plus expectation of xn, right? And what is this? This one is here, right? So what is the mean? The mean is equal to p, right? And this one is also equal to p. And then also p. So what is the whole thing? N times p. Okay, n times p. Any questions? Now we want to get to variance. Okay, this one is more difficult. Okay, let me try to remind you something. We discussed this before. You want to check your note. Okay, the book is much simpler than what I'm talking about here. So you want to pay attention to what I said. Okay, we say variance of ax plus by. What is this equal to? This is equal to a square vx plus b square vy and plus 2ab times covariance xy. Okay? Also, I talked about this before, minus. If it is minus, it is minus here. Okay? Okay, so let us try to get variance, okay? Get variance. Let me erase this here. The same thing, we are trying to get variance of x, okay? And for variance of x, it is equal to variance of x1 plus x2 plus xn, okay? So the same thing here, but in this case, it will be a little bit more difficult, okay? But let us try to simplify all these things, because we know covariance xi xj should be equal to 0, because we say in this case, okay, we say in this case, each trial is independent of each other, right? The trial is independent of each other. So what does that mean? If I is not equal to j, then because these two variables, they are independent of each other, so the covariance is equal to what? Is equal to 0. So in this case, because we say if it is Vx plus y, it is equal to Vx plus Vy, right? And of course we have two covariance x and y, but this one is equal to 0. The same thing if you have Vx plus y plus z. Okay, then what do you have? You have variance of x plus variance of y plus variance of z and plus 2 covariance xy plus 2 covariance xz and plus 2 covariance YZ, right? But X and Y, they are independent of each other, so this one